45, shadow length. These are all exactly the same. A 12-foot marble statue in Italy casts a shadow that's 15 feet long, right? So you draw a picture. You can't do these without a picture, otherwise you're lost. So you have a 12-foot thing, right? And he casts a shadow, so this would be your shadow. And the shadow is 15 feet long. So the sun is coming down and doing that to you, right? Nice little right angle, because we're assuming it's not the Leaning Tower of Pisa, because then we couldn't do this, because it's not straight. At the same time of day, which means the sun's at the same angle of elevation, a wall casts a shadow that is 8 feet long. So you have this wall, and then it casts a shadow that is 8 feet long. What are we asking for?
The other wall.
The height of the wall, right? So you put a x here because we have no idea what the heck it is. Right?
Mm-hmm.
Okay. Set up a proportion.
So the x over 8 over 15.
X over 8 equals 12 or 15. How? I mean, seriously. Did you even try?
No, I just saw it looked hard. I had an arrow next to it. I did some of them.
It looked hard.
I did.
You didn't even read it, and it looked hard.
Number 15. No.
Cross, multiply, blah, blah, blah.
8x.
Yeah. I think you know how to do the rest of it. None of these are hard.
What was number 15?
15.
That's the one. Oh, that's another page.
Yeah, well, that's all right. 15. Let's see if I can squeeze it in down here. 15. S minus 2LW divided by 2W plus 2L is equal to H. And we're looking for W by itself. What should you do first?
Get everything and get the W alone?
No, well, that's the... See, you say things like that. That's the last step. So if you say the last step first, guess what you're not going to get to?
Get rid of the fractions.
Get rid of the fractions. So how do I get rid of the fractions?
Multiply everything by 2W plus 2L.
Right. So that'll give us, it'll cancel out on this side, and you get S minus 2LW. And it multiplies the H on the other side, so you get 2W plus 2L times that H. Okay. Now remember what we're trying to solve for. W, here, here. What do you want to do next?
We get
distribute. Get the parentheses out of there because one of the W's is stuck on the inside. Now, if the W wasn't on the inside, I could care less. Or, I should say, if the W's not on the inside and the W's not on the outside, I could care less. But since one of those cases is there, distribute, and you get S minus 2LW equals 2HW plus 2HL. When you start working with variables, you try to keep them in alphabetical order. That way you don't lose pieces. All right, well, here's your W, here's your W. What should you do?
we got to add the S out on the one side and take it to the other side.
Why are you looking at the S? W's.
We don't have W alone, right?
Yeah, but I want to get the W's on the same side. That should be your first goal. Because if you don't do that, you're going to have things just moving left and right all over the place. So subtract 2HW? You can. So you get S minus 2HW minus 2LW is equal to 2HL. Okay, now your W's are on the same side. Now what? Subtract the what? Subtract the S, so you get negative 2HW, negative 2LW, 2HL on the other side, minus S. Now, what are you starting to not like about how we've written this? You like the way it looks. Okay, what would I not like about this? How about that?
It's taking too long.
No. It's going to take this long no matter what you do. But what looks weird, out of place?
Negative.
The negatives. I don't like those negatives at all. Because we're trying to solve for W, this is going to give us a negative expression, and that just gets messy. So what can I do to everything?
Multiply by -1.
Multiply by -1. It makes our life a little bit easier. So this is 2HW plus 2LW When I multiply this by -1, this first one becomes negative, the second one becomes, and I'm just going to switch their order. Remember, if you switch the order, it actually changes sign when you commute over subtraction. Now that looks a little prettier, doesn't it? So you're always trying to make things look nice in math because it usually helps you get the answer right. Again, we're trying to solve for W, so what should I do with it? Stare at it. Okay.
Well, you can split them all. You can divide out 2h by 2h and 2l.
Yeah.
Or subtract it, don't we?
No. Yes, you do.
I'm gonna divide by -2 and 2.
No. You're trying to solve for W. They're there. They're sitting at you, staring you in the face.
You don't divide by nothing.
No, definitely don't. Never divide by what you're trying to solve for. Ever. Because it could be
So
equal to.
multiply.
No.
You can't
I want to add them together, so how do I add them together?
How can you add them together?
2HL, 2W.
Let's go back to the beginning of the year. 5x plus 3x
But they're
equals.
not like terms.
Yes, they are. 5x plus 3x. How do I?
It's not
Shh,
good.
shh, shh. How do I add those two together?
8x.
How do you add them together?
So 3 and a 5.
Distributive property. How do I use the distributive property?
Pull out your like term.
Pull out your like term, which is x, and you leave behind 5 plus 3. Don't these have like terms?
Why just to say what property?
Take out the w. What?
Why just to say what property?
Uh-uh. Take out the w. So if you kick out the w, left behind is
2h plus
2h plus 2l. You have to recognize it. You have to go, oh, they both have a w. Let's kick it out. Because that's what you're trying to solve for. And when you kick it out, you get one w. Which is very nice. And then you're going to divide that across. So you get w is equal to s minus 2hl divided by 2h plus 2l. Yay! Anytime you have two letters that you're trying to solve for in two different locations, you're always going to use the distributive property. You're going to factor it out and divide whatever's left over to the other side. It's constant. Now, if your variable only ends up in one place, you just do it like normal. But once it ends up in two different locations, you have to get them on the same side, factor it out as a single variable. I think that covers about all of them. Ready?
Mm-hmm.
Today's stuff isn't that bad. Test is what? Oh. Can I erase yet?
You can start on the top.
I can start over here in the flu area.
You take all that whole row right
Today is page. Today is 7-1. Rational exponents. Everybody was afraid of the rain.
there. Oh, you took all of it. Thank you.
Yeah, I get to tape all of it and we can watch it later. So rational exponents. Rational means to you and me and everybody else on the planet Earth.
Not my wife.
We're not talking about that.
Oh.
Rational in terms of numbers. What kind of numbers are rational numbers?
Whole numbers.
No, definitely not.
Integers.
Fractions. They're fractions. Rational numbers are fractions. Rational expressions. Remember rational expressions? Rational expressions are, x plus 1 over x plus 2. That would be a rational expression. A rational exponent, then, are exponents that are not whole numbers or integers. They are things like 2/3, 4/5, weird numbers like that. So we need to practice working with them. And all I have to do for you is to review a few things real quickly. Laws of exponents. Remember laws of exponents? A to the m times a to the n is equal to
2a. 2mn.
a raised to the mn. No, it is not. Cross that out. A to the m times a to the n is? A to the m plus n. You add the exponents. X squared times x cubed is x to the fifth, because you add the exponents. All right, if you have a to the m over a to the n, what do you do with the exponents? Subtract them, so you get a to the n minus n. If you have a to the m raised to the n, and this is the one we're going to use most often, well, it's going to become one of the more important ones. What do I do with the exponents here? Multiply them, you get a to the mn. This is the one you memorize so you don't mess up the first one. Power to a power you multiply, the other one you add.
Just focus on Tori. He was right.
You're behind him. A to the negative n is equal to 1 over a to the positive n. What else comes in handy? I think that's about it. Well, other than something like a to the m, a to the n, raised to the p.
A-M, P,
A,
A-M-P.
MP, and A, oh, I should say P, I'm sorry, P. B, B to the NP. So, that last one is the one everybody messes up when they see something like A plus B raised to the third power equals, and that's the one that they mess up. A plus B raised to the cube has nothing to do with any of these because none of these have a plus or a minus. This one you have to remember is A plus B times A plus B times A plus B. And what takes over after that? Foil, 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 distributive, distributive, distributive. And it becomes a horrible mess. It's a cubed plus 3a squared b plus 3ab squared plus b cubed. Sadly. Okay, so when we're working with rational exponents, we have to remember the laws of exponents. And they do not change because the exponential expression looks, well, different. For instance, let's do a little review. This is number 8. We should be able to go through these rather quickly. 5x to the negative 2, y over x to the 4th raised to the negative 2. Remember these way back when? And you all complained and whined about them, and now they're back.
Just like you.
Yeah. So what should I do first?
Inside of parentheses.
Nope. No, definitely not. That would make things horrible. What should you do? You could, but before you flip it, simplify the inside. Is there anything that we can do on the inside to make it look nicer?
Take the X out, the X to the second and bottom.
Yeah, I can take this x to the second to the bottom. That makes it x to the 6. And that way you have no negative exponents on the inside, and plus you only have 1, 5, 1, y, and 1 x. X to the 6.
X to the 6.
One instance of an x. Instead of having
I
it.
thought you subtracted the 2.
If you bring this one down, what
Change
happens
the
to the
sign,
negative
yeah.
2?
Goes to the bar, change the sign.
Becomes positive, and then you can add it to the 4. Now that's the shortcut. Technically, you're supposed to go x to the negative 2 minus 4, which would be x to the negative 6 on the top, and then you drop it. It's easier just to take the smaller power, drag it to the right side, and add them. Raised to the negative 2. Now what should we do? Now you can flip it. So the reciprocal makes this x to the 6 over 5y. Now it's raised to the positive 2. Now what can we do? Square everything. Power to a power you multiply. So x to the 6 squared, x to the 12. 5 squared, 25. Y squared, of course, is just y squared. See? Easy. Just reminding you how to do these things. No. These can't get hard. If all you have to do is follow the laws of exponents. Here's number 12. Y squared raised to the 5 halves. You see something like this on a test, you'd be like, thank you. Because it's so easy. What do? Well, power to a power, what operation do you use?
Multiply.
Multiply. So what's 2 times 5 halves? It's 5. So it'd be y to the If you don't see that, go off to the side and go 2 over 1 times 5 over 2. What happens to the 2's? They cancel and you're left with 5. That's a very nice one, don't you think? Don't you want to see it on the test? Guess what you're not going to see on the test? You're not going to see that one. And you're not going to see this one either. I just want to get you used to fractions. Y to the 6/7 over y to the 3/7. Okay. What do you do with the exponents here? You divide the exponents? You subtract the exponents. Because when you have a base over a base, you subtract the exponents by the law. So what's 6/7 minus 3/7? What is it? 3/7. So this becomes y, the base, raised to the 3/7. See? Nice and easy. How about, this is 22. B to the 2/5 times b to the 2/15. Why is this one a little bit different?
Different bases.
No, the bases are the same, bb.
Oh, I mean the exponent base.
The exponent, denominator. The exponent denominator. So what do I need between these denominators?
LCD.
So this is 2/5. What am I going to do with these exponents?
Multiply the.
I'm multiplying the bases. What do I do with the exponents?
So
Come back over here. Multiplying the bases. What do I do with the exponents?
Yeah.
Again. So it'd be 2/5 plus 2/15. Common denominator?
15.
What do I have to multiply top and bottom by over here? 3. So this becomes 6/15 plus 2/15, better known as 8/15. Is there a common factor in either of those? 3 and 5, bunch of 2's now. So my final answer is b raised to the 8/15. This is probably the only place I use a slash for a fraction to keep the exponent kind of tight, because it's hard to write it b to the 8/15. It gets very weird that way, and sometimes when you write it on paper, the power gets too big, and then you forget it's a power. So it's probably one of the only times I'll use a slant for division rather than a horizontal line. All right, so that's rational exponents. Isn't that easy? You just have to remember when to add, when to multiply, when to subtract, what to do with negative exponents and all that fun stuff. So how about, let's see, where's it going? This one. I can stick it here. 32. -4, y to the -3/4. I just want to simplify the expression. Simplify the expression. What can I do? Get rid of the fraction, just erase it?
Multiply everything by.
Can't multiply anything.
Yeah, I'm
It's
throwing
not-
out ideas here.
It's
and
not
you-
an equation. What's wrong with this expression?
It's negative.
What's negative?
The base.
The base is negative?
The power is negative.
The power is negative. No, that's all. I could care less if the 4 is negative. 4 being negative is perfectly fine. -4. But -3/4 is something that you don't want to see. So where does it belong? On the bottom. So how do I write it?
-4.
-4 is not going anywhere. He's fine.
Oh, why?
Over.
Why? The Y goes on the bottom.
The y goes in the bottom. Y raised to the
Positive 3/4.
positive 3/4. How about this one? -8, x to the 2/3, y to the -5/6. How do I simplify that expression?
Drop the y to 5/6.
Throw the y in the bottom. What about the 8?
Stays up top.
Stays up top. So it becomes -8 x 2/3 over
Y to 5/6.
y to the 5/6. You see negative exponents on the wrong side of the fraction. Put it on the opposite side. Okay. What else do I got here? Oh, yeah, we got to talk about these. So what happens if I write something like 9? Well, let's just start with 9. and I raise it to a half power. Nothing to flip. It's not negative or anything. It's just
4.5.
9 raised to the 1/2 power. What I'm trying to say here is, what's 9 squared?
81.
81. We can calculate it out. So what I'm thinking is, well, I should be able to calculate out some answer, at least on a calculator. So 9 raised to the 1/2 power must be some answer, some number. What's another way of writing 9?
9.
3.
3 and 3, which is 3, which is 3 times 3. Yes, great. 3 times 3 is, 3 times 3. 3 squared. So I can write this as 3 is 9. Of course it's 9. 3 squared. And it's still raised to the 1/2 power. But power to a power, what do you do?
Add. Power to a power, you add.
No, you gotta multiply.
Power to a power, you multiply. That's the one you memorize. The other one is add. So what's 2 times a half?
1.
2 times a half is 1. So this becomes 3 to the first power, better known as 3. So 9 raised to the 1/2 power is 3.
What?
What? What do you mean, what? 9 is the same thing as 3 squared.
Okay.
3 squared to the half power is 3. Therefore, 9 to the 1/2 power. Notice all
But
these.
if you just put in the calculator, it's just gonna say
Yeah, great. Wonderful. Calculator will do our thinking for us. We won't have to do any thinking whatsoever.
I don't want to.
So if I have 25 raised to the 1/2, what's another way of writing 25?
5 squared.
5 squared. So you get 5 squared raised to the 1/2, which is equal to 5. Because the 1/2 and the 2 will multiplicative inverse each other away. Okay. Let's change it up then. 8 to the 1/3 power. It's going to be 2. What do you need a calculator for? Because 8 can be written as 2 times 2 times 2, which is better known as 2 cubed, raised to the 1/3 gives you 2. Awesome. So, here comes the next part of it. That's the basics of it. If I have 27, and I have it raised to the 2/3 power. Now notice what I've done. Instead of 1/3, now I'm talking about 2/3. And the 2 and the 3 have their own thing that they have to do. It's not a single power anymore. What we're going to do is separate it. So how can I separate 2/3? Well, I want 2/3 to become the product of two numbers. So what two numbers multiply together to give you 2/3? 1/3 times 1/3 is 1/9. We're not adding them, we're multiplying. What two numbers multiply together to give you 2/3? I'll be patient. You're not going to be able to do it on a calculator. A calculator gives you answers. It doesn't break things apart. So what two numbers that I can multiply together give me 2/3? I'll give you a hint. One of them's a whole number, the other one's a fraction. What is it? 1 and 2/3 is like mixed numbers. No, we're not talking about that.
3 and
3 and
2.
no,
3 1/3.
not 3 1/3 because 3 times a third is 1.
Oh.
Closer though. One's a whole number, like 1, 2, 3, 4, 5. The other one's a fraction, and guess what fraction it should be? No,
That's good.
it already is 2/3. But say the last word,
Third.
third. So one of the numbers is
Third.
a third. So you're right, 1/3. What's the other number have to be?
6.
No, because 1/3 times 6 is 2, not 2/3.
2.
2. Specifically 2 over 1. 2 times 1 is 2. 1 times 3 is 3. Oh, let's try this again. If I have 5 sevens and I want to split it into two numbers, what are the two numbers that I can split it up into?
1/7.
1/7 and
5 ones.
5 over 1, or just plain old 5. Wow. 9 over 4.
1/4 and 9.
1/4 and 9. Are we getting the hint now?
Yeah.
Oh my god. It's funny. You're all like, 3 and 1/3. Okay, so what I want to do with this exponent 2/3 is I want to break it up into a third, and a 2. Just a third and a 2. And they're going to be multiplied together. But thank God it's in the exponent, because when you go power to a power, they... Power to a power, they... Josh?
Multiply.
So
Multiply. Multiply.
the power to the power is with a
Power to a
parentheses.
power, you multiply.
Has a parentheses.
They're really close together, yes. Okay.
These two are really
So,
close.
I have an option. I could put the 2 next to the 27 and the 1/3 on the outside. Or I could put the 1/3 on the inside and the 2 on the outside. Which one sounds better? Think of it this way. If I put the 2 on the inside, that's 27 squared. Do you want to figure out what 27 squared is? I don't either, because I don't know what it is. So I think the 1/3 should go on the inside. Let's see what happens. 27 raised to the 1/3 power, all squared. Because 2 times 1/3 is 2/3. All right. How do I write 27?
3 cubed.
3 cubed. So this becomes 27. Oh, no. That does not become 27. It becomes 3 cubed raised to the 3rd raised to the 2nd. I know that's a lot of parentheses, but that step literally is in your head. You try to figure it out in your head. You know this is 3 cubed, and you know it's raised to the 1/3. Guess what happens to those two powers? They cancel. So you get 3 in the inside. And 3 on the inside with a 2 on the outside means this is equal to 9. So 27 raised to the 2/3 power is 9. Oh, we need to do more of those. I can see it already. 81 raised to the 3/4. 81 raised to the 3/4. What are the two fractions I can get out of, well, two numbers I can get out of 3/4?
1/4 and 3.
1/4 and 3. Yeah, now he knows it.
It's just
Beat him down. All right, so what we're going to do is we're going to change 81 into something that has a power of 4. That's our hint, this 4 over here. So what can I write 81 as a power of 4? What raised to the 4th power? 3 to the 4th. Because it would be 3 times 3 times 3 times 3, and 2 of the 3's become 9, and you get 9 times 9. So you get 3 raised to the 4th, that's your 81. Then you deal with your 3/4, make the first one 1/4. Make the second one 3. Do you see it? Is that okay? It looks messy, but it works out rather nicely. What happens to the 4 and the 1/4? They cancel, and you're left with 3. 1. Well, 3 to the first. So you have 3 on the inside. What's left on the outside? 3. And 3 cubed is 27. So that means 81 raised to the 3/4 power is the same thing as 27. Isn't that insane? How about 25 raised to the negative 3/2 power? Now there's two things to worry about. The 3/2 power and the negative. What's the negative automatically going to do?
Make it a fraction.
It's going to make it a fraction. So we have to take care of that at some point. I'm going to take care of it at the end. You can do it at the beginning. So how do I write 25?
5 squared.
5 squared. It's going to get raised to what power?
1/2.
1/2 because of that 2. And then this whole thing is going to get raised to negative 3. Don't lose the negative sign. Like I said, you can take care of the negative at the beginning if you want. You just create the fraction at the beginning. But I like doing it at the end. And it's just preference. All right, what's 5 squared raised to the 1/2?
5 to the first.
5 to the first, better known as 5. Raised to the negative 3. Well, how do I figure out what 5 to the negative 3 is equal to?
You drop it to the bottom.
Drop it to the bottom, so this becomes 1 over 5 cubed. What's 5 cubed?
25 times 5.
Which is
125.
125. So 25 raised to the negative 3/2 power is 1/125. Now be careful. The biggest mistake I've seen here is people making the answer negative. Notice this answer is not negative. It's just really, really, really small. So when you see negative exponents on numbers, it means you're talking about a very small value, generally. All right. So that takes care of that piece. It's just a lot of little pieces here. I think I can fit it here. 44. 44 is a little bit longer. 8, x to the negative 1/5, y to the positive 1/3, times negative 3, x to the negative 1/4, and y to the positive 1/6. Remember these things? First things first. There is no exponent sitting on the outside of these parentheses, which makes this a nice, easy problem. So the only thing you have to do is multiply everything together. What allows me to multiply 8 and negative 3 together?
Distributive.
No. Do you see any pluses or minuses here? That's not a minus, that's a negative. Distributive property only works as a number on the outside multiplied over a sum or a difference. That is definitely not distributive property. Commutative property, where you flip the order of the numbers. So we would take the negative 3 and flip it with the x and the y, and it becomes 8 times negative 3. So, remember, I'm going to test on this on the final. That's why I keep going back to it. 8 times negative 3, negative 24. X to the negative 1/5 times this x to the negative 1/4. Uh-oh, something's wrong. What can I do? What do I do with the exponents?
Find out who gave that.
Well, you're going to add them together, so it's negative 1/5 minus 1/4. What's the common denominator? 20. So you'd multiply top and bottom over here by 4, so it's negative 4/20. Over here, top and bottom by 5/20. And negative 4/20 minus 5/20 is negative 9/20. So it's x raised to the negative 9/20. Okay. And then we're going to multiply the y's. Just connecting them so I can keep a focus. Y to the 1/3, y to the 1/6. What property allows me to multiply those two together? Which is commutative. Wait for someone else to answer.
No, she's doing good.
And if you multiply them together, what are we going to do with 1/3 and 1/6?
Add them together.
Add them together. So we have 1/3 plus 1/6. Common denominator?
6.
6. So this becomes 2/6 because you're going to multiply top and bottom by 2. Plus 1/6. And 2/6 plus 1/6 is
3/6.
better known as
1/2.
1/2. So we get y raised to the 1/2.
We have to have it 1/2.
1/2. You write 0.5, I'd be really worried. So basically, this whole first section is just a review of all the laws of exponents mixed in with fractions. Makes life nice. We haven't gotten to the worst ones yet. Did that one. No, we didn't do that one. Let's do that. This is 32. I'm doing enough so that you can see a variety of them, because these are a little strange. I'll admit it. Oh, that's a foregone conclusion. We already figured that one out. When you see fractions, you do have to slow down. You have to make sure you're getting the laws of the fractions right with the laws of exponents. When you have base times a base, you're going to be looking for common denominators. When you have power to a power, you're just going to multiply them together, top to top, bottom to bottom. This one is a little complex because there's a lot going on. So what should I do first? Simplify the inside as much as possible. Can I do anything with a 16?
No.
Nope. Can I do anything with the a5 over a to the negative 1? Yeah, what is it? I would move this one up. Becomes positive a, and then a to the 5th times a is a to the 6th. What do we do with the b's? No. I wouldn't do that. Take the smaller one towards the bigger one.
Subtract them.
So take the 6 and bring it up. So that becomes positive 6. B to the negative 2 times B to the 6.
It's 4.
B to the 4. So it ends up all on the top. Now you can do the laws of exponents. Want that? You could do the laws of exponents if you want. Subtract, it would be 5 minus a negative 1, that would give you 6. Negative 2 minus a negative 6, that would give you 4. But I find it better if you just take the smaller power and drag it towards the other one. And that way you always get a positive answer. So this whole thing is getting raised to the half. Great. What's 16th to the half power? It's 4. Because 16 is 4 squared, and then the square and the half will go away, and you're left with 4. Huh. Wait a minute. I know something else that I could do to 16 and get an answer of 4. What is it?
5.
No one knows?
You said.
We'll come back to it. Something you could do to the 16 and its answer is going to be 4. Something you could do to 25 and the answer is 5. Something you can do to 9 and get 3. Square root. So I wonder if there's a relationship between a half power and a square root. Think about that, because that's next. So 16 to the half power is 4. A to the 6th power to the half power is
3.
A to the 3rd. And B to the 4th half is 2. And there's your answer. Not that bad. It's actually pretty simple. Just 3 more. 66. 2y to the 1/3 power plus y to the negative 2/3 power. And the directions, there's directions for this one so you don't wander around aimlessly. Write as single expression. Because there is something else you could do to this thing. You could factor it, and we'll do that next. But we're going to write this as a single expression. Why would I want to write this as a single expression? Just for the fun of it for now. So, when you look at this, and I want to combine this as one expression, a fraction, actually. I know it's a fraction y, negative exponent. So probably the best thing to do is to change this negative exponent into the fraction form. So this becomes 2y to the 1/3 plus 1 over y to the 2/3. Okay. Now how do I force this thing to be one expression? What do I need? This is the same thing as 5 plus 1/3. Or get a what?
LCD.
Common denominator. Okay. So if I get a common denominator, I need a denominator over here, so I'll put a 1 under it. What do I multiply top and bottom by? Y to the 2/3. Multiply this by y to the 2/3 in the top, and y to the 2/3 in the bottom. Now if I do that, over here, am I missing anything? Yeah, so don't do anything to this side. So let's see here, 2, that's on top for sure. Y to the 2/3 times y to the 1/3. Done. What do I do with the exponents? Y to the 2/3 times y to the 1/3. What do you do with the exponents? Add them. 1/3 plus 2/3 is?
3/3.
3/3, better known as 1. So that'd be 2y. Plus, because I have a common denominator, I can add the tops. All over y to the 2/3. Isn't that crazy? But that's writing it as one expression. You want to do one more? That's the one that usually trips people up. How about something that looks like this? 3x to the negative 1/2 minus 4x to the negative 2/3. This is about as ugly as I can make it. What should I do first if I'm going to write it as a single expression? 9. Definitely not 1.
Put it in fraction form?
Yeah, I want to put it in a fraction form. So how do I write 3x to the negative 1/2 as a fraction?
1 over.
Why are we doing 1 over? Well, are you moving the 3?
X on the bottom.
Is 3 raised to the negative exponent that I don't see?
It's the
Is this 3 attached to the negative 1/2?
It's the
Is the 3 a base of negative 1/2?
No.
I'm asking. I really need to know. Because I have to worry, because if you have 3x squared, is 3 being squared? No. So that 3 over there is definitely not being raised to the negative 1/2. You worry me. So what stays up top?
3.
3. What goes in the bottom? X to the 1/2. Minus, what stays in the top? 4 over x to the 2/3. Now I need to get a common denominator. What do I do?
You add them together, you need 6 LCD.
Well, before you do that,
Can't do that.
what's missing on this side that this side has?
Negative sign.
Now, what is missing in the denominator of this one that this denominator has?
2/3.
Just 2/3? X to the 2/3. You can't separate these. This is one number. Remember, 5 to the 1/2 is going to be different than 5 to the 2/3. So we're not concentrating on the 5. We're worried about the powers. So this one is missing x to the 2/3. Multiply it top and bottom to get the common denominator. What's missing on the other side?
1/2.
So
X
just
1/2.
1/2. Yeah. X to the 1/2, top and bottom. Why would you do anything different? I don't know. Okay, I might use this marker. So over here we're going to get 3x to the 2/3 minus, because now they have a common denominator, I can just go straight across. What's on the other side? 4x to the 1/2. And it's going to be all over.
X 2/3 and X 1/2.
All right, so what do I do with 2/3 and 1/2?
Find the LCD.
So 2/3, what am I going to do with them?
Add them together.
Add them together. So 2/3 plus 1/2. What's common denominator?
6.
So you go 2, 2, 3, 3, and you get 2 plus 3 over 6, better known as?
5.
5, 6. So this would be x to the 5, 6. And that would be a good answer. Not a pretty answer, definitely not pretty, but it is the answer. There. So I think that means one more thing. Yeah, one more thing. Just one more small detail about rational exponents. This is 72. Notice this has a lot of problems. 18x to the 5/3 minus 6x to the 11/8. Now, they don't do it properly, but we'll do it anyways. We're going to factor this thing. So you have to be given directions, otherwise you wouldn't know what to do. Factor. Now, when you get to college algebra, we're going to treat this a little different. But for here, we're going to do it the book style, just to keep it simple. What factors do these two terms have in common? Well, they definitely have a 6 in common, so I'll kick out the 6. What else do they have in common? An x. Now, the book tells you to just factor out the x. When we get to college algebra, I'm going to change that all up on you and it'll be something else. So I'm going to kick out a 6 and I'm going to kick out an x. So what does that do to x to the 5/3? Well, that's the same thing as going x to the 5/3. Remember when I taught you factoring that you do it by division? And this is one of those cases you might actually want to look at the division. What do you do with the exponents when you divide x to the 5/3 divided by x? Subtract. So it would be 5/3 minus. I'm not looking at that. I'm looking here.
Minus 1.
You're factoring out an x, so it would be 5/3 x to the 5/3 divided by x minus 1. All right, change that 1 into? No, well, you could, but then 3 over 3. So this is 5/3 minus 3/3, better known as positive 2/3. So here, it's going to be 18 divided by 6 is 3. And x to the 5/3 divided by x is x to the 2/3. Okay. And then over here, negative 6 divided by positive 6 is negative 1, so we'll just get the negative. And then we have to do x to the 11/8 divided by x. X to the 11/8 divided by x. So this becomes 11/8, 11/8 minus 1, but we're going to write that as 8/8. That makes life easy. So that becomes x to the 3/8. So up here, I'm just going to write x 3/8. And that's what the book considers factoring these expressions. We'll just stick with the book.
What do you have different? I see.
Are we doing another one?
Yeah, because I didn't get it.
Well, it's a little weird, but that's really what's going on. When you say factor, you're pulling out common factors. They both have a factor of x. In this case, we're ignoring the powers and we're pulling out the x. That's one reason I don't like the way they do it, but that's the way they do it, so I want to give you what they do. So if you have 24 x to the 1/2, y to the 2/3, minus 18 x to the 2/3, y to the 5/6, plus 6xy. It's horrible. And I'm saying, what is the greatest common factor between these three things?
6x1.
The book says, notice I'm not agreeing with the book, but that's okay. We're going to kick out a 6xy. What's left behind? Well, 24 divided by the 6 is 4. Then we get to x to the 1/2 divided by x. X to the 1/2 divided by x. So this would be 1/2 minus 2 over 2, better known as x to the negative 1/2. That's one reason I don't like the book's method, but that's all right. So I'm just going to write x to the negative 1/2 in here for now. We'll just go by the procedure and then we'll simplify it afterwards. Then we have this y to the 2/3 divided by y. So let's see here, y to the 2/3 divided by y. What do I do with the exponents? Subtract, so you get 2/3 minus 3/3, better known as 1. And then 2/3 minus 3/3 is? Negative 1/3. So this becomes y to the negative 1/3. Again, we'll deal with that later. Negative 18 divided by positive 6. Negative 3. X to the 2/3 divided by x. Well, that's the same thing as y to the 2/3 divided by y. So that'll be x to the negative 1/3. And then y to the 5/6 divided by y. All right, let's see here. Y to the 5/6 divided by y. Oh, that's going to be, well, do this. 5/6 minus 6/6, better known as negative 1/6. So we get y to the negative 1/6 plus 1. Because 6xy divided by 6xy is 1. Now that's the book style factoring. The problem with the book style factoring is if these powers are not bigger than 1, you're going to get negative exponents. They're going to keep their powers bigger than 1. Did they? Yeah, they kept them bigger than 1. But there is that possibility that they're smaller than 1, and then the book's method gets a little messy. Because now I have to take all these negative exponents and put them at the bottom. So this becomes 6xy times the quantity, what stays up top?
4.
That 4, what goes in the bottom? X to the 1/2, y to the 1/3, minus what goes in the top? 3, what goes in the bottom? X to the 1/3, y to the 1/6, and then we get this plus 1. And that's the only reason I don't like the book's method. It makes things actually, well, messy.
But when you have like a number bigger on the outside, and the X is like, you know what I'm saying? Like, would you have to take have an X on it?
The book is just saying pull out an X, pull out a Y. That's all they're saying. What would I do? I would pull out the smallest power. So the smallest power of X is X to the 1/2, so I would yank that out. The smallest power of Y is Y to the 2/3, I'd yank that out. And then what gets left behind will always be positive. Will always be positive. But that's my style, and this is the style you need when you get to like calculus. Yeah.